Hi guys, welcome to our lesson for today. So today we're going to be looking at revising Euclidean geometry, right? So firstly, we're going to look at exactly what is Euclidean geometry all about in terms of the chart that we're going to try and use, and then talk about some concepts that have to do with Euclidean geometry that you need to be able to understand by now, and then at a later stage solve some questions and then throw in some theorems that you really need to make sure that you are familiar with. So let's just jump right into it. So when we talk about Euclidean geometry, right, remember there's what we call an axiom, there's what we call a theorem, there's what we call triangles. So there's theorems that have to do with triangles, there's theorems that have to do with quadrilaterals, there's inductive reasoning, where you see and measure, and then the deductive is just making a statement without a proof and then proving it, which will then be the theorem at the end. Now, what do you know about triangles? That's what I want you guys to think about, right? We know we have types of triangles based on their angles, right? Meaning your acute angled triangle, your obtuse angled triangle, your right angled triangle. That is classifying the triangles based on the angles, right? And then we have another way of classifying triangles using the sides, right? But now the nice thing about sides is as soon as we get to sides, we also even use the angles with the sides, right? Because there's some theorems that we throw in there. This is when we talk about a scalene. A scalene triangle simply means that no sides are, let me just write this correct, no sides are equal, and if no sides are equal, then simply no angles are equal, right? And then the other one will be the isosceles triangle, which means two sides are equal, two base angles are equal, and then lastly, it will be the equilateral triangle, which is all three sides are equal and all three angles are equal. So that's what you need to know, just as the foundation of a triangle. Now let's do what is the real thing about the triangle, right? We know that the triangle has sum of angles internally, right? So the interior angles, they add up to 180 degrees. Whereas with the exterior angle is equal to the sum of interior opposite angles. Now I want to show you dramatically, right? Not that I'm gonna do drama, no, I'm just saying I'm gonna draw a diagram for you to be able, or diagrammatically, guys. So I will have this triangle here. If I have X, Y, and Z there, if you add all these angles, it must give us 180 degrees. And our reason that we normally use here is to say sum of angles in a triangle. And that's all, right? Because you always need to give reasons when you're making statements. Now with this one, the second theorem, because it is actually a property or theorem rather, this has to do with an exterior angle of a triangle. But before we talk about this, I want to clarify something here. You can't talk about an exterior angle of a triangle when none of the sides of the triangle are extended, right? So you can only talk about exterior angle if one of the sides of that triangle is produced, which simply means extended, because mathematically we use the word produced, right? Now, that simply means if I say this is my A, B, C, and then they extend it to D, then this angle outside here between AC and DC will be equal to angle A plus angle B. That's what we mean when we say an exterior angle is equal to the sum of the interior opposite angles. So meaning I will say C1 and C2 there. So C1 will be equals to A plus B, and then my reason for that will be exterior angle of a triangle. Just short like this, you don't need to write full words, please. This is how we do our geometry. Also, what do we also know about triangles? We know that we can claim triangles to be similar if we have AAA, right? Not like an insurance company. No, this simply just means these are equiangular triangles, angular triangles, right? That's what the AA means, the triple A means, equiangular, right? So meaning if I have two triangles like this, they don't necessarily need to have the same size, but this angle at the top will be the same as that angle. The one on the right here will be the same as the one on the right there. The one on the left will be equals to the one on the left. That's what it means that I have AAA, which is the same as just saying equiangular triangle. So if I can prove that all three angles are equal, right, when I correspond them, then I can claim those shapes to be similar. But what if now both angles and sides are now equal? This is where we now talk about the concept of congruency, because congruency has to do with things that are identical, right? Whereas similarity is things that are in proportion with one another. Congruent, identical. Similar, proportional. So for things to be identical, all sides must be equal, or one side or one pair of sides and all the angles must be equal, meaning two pairs of angles. Side and an angle and a side, this is normally like a V, right? Where my side is there, my side is there, and then my angle is here, right? So it is side, angle, side, which is a side and an included angle and a side. That's why I'm saying it's something of this nature, right? And then you can close your triangle there, and then it will be the side angle side. Then the other one is RHS, which is a right angle, hypotenuse side, and then one more side. Remember, the hypotenuse side is the longest side of a right angled triangle, right? With these guys, please note this. You don't need to prove all four properties when trying to talk about congruence. If you prove one of the four, then the other three will be true by default, because congruency simply means this thing is the same, exactly the same as this thing. You see, so if I prove one property in these two things, then all the other properties will hold. So that's what you please need to make sure that you are clear about. Not that you must prove all four, no, just one, and then the others will hold as well. Now, one last thing is what we call the midpoint theorem, rather. The midpoint theorem is when we talk about having the midpoint of this side and the midpoint of that side. If I join them, this line, which is a third line, is normally parallel to the third side of the triangle, right? Provided that those points on the sides are midpoints respectively, right? So that's what you need to know, please, about the midpoint theorem. So to quickly just apply this and show you what I am trying to say, if we have D and E as the midpoints of AB and AC respectively, then we know that the DE will be parallel to BC. I just showed you that. So this DE here will be parallel to the BC there. And then also DE will always be half the size of BC. So if DE is 2, then BC will be 4 units, like that. They have a relationship of 1 is to 2. And then if D is the midpoint of AB and the DE is parallel to BC, then we know for a fact that AE will be equals to EC. And then you can try and talk about the midpoint theorem there, right? So that's what the midpoint theorem is all about. So you need to please make sure that you are clear on that. One, The sides that are on the left and on the right of the triangle, they must be bisected. When you join them where they are bisected, the third side becomes parallel to the third side of the triangle, and then lastly, it becomes half the side of the triangle. So that's what you please need to make sure that you are clear with. Please, let's take a quick ad break, but I want you to please stay tuned, because when you come back, we're then going to apply this midpoint theorem so that you can see how exactly do we use it in diagrams. Stay tuned, I'll be back just now. Hi guys, welcome back to our lesson. So we are still looking at revising Euclidean geometry, right? So now we're going to look at some questions that involve using the midpoint theorem, and then try and see how do we answer questions that have to do with finding unknown angles and finding unknown sides, and using the concept of the midpoint theorem. But for now, let's just look at exactly what is it that you need to know in terms of your midpoint theorem. So firstly, some strategies that I want you to take here is you always need to transfer all the given information onto the diagram. So for example, if I have maybe a diagram like that, right? And they say to you, this is A, this is B, this is C. And then the statement says to you, maybe AC is equals to BC. I need you to go to the diagram and show it with a one-liner like that or two-liner like that to mean those lines are equal. Because as soon as you do that, you will see that you can then say angle A is equals to angle B, because of it becomes an isosceles triangle. Do you see? Now I've added an extra thing based on being told one thing, but I can only do that if I transfer the given information onto my diagram, please. And then from there, you ask yourself, what does the given information tell you, right? This is the implicit information, as I said. So based on the fact that I know that AC is equals to BC, I will then say implicitly, they are telling me that this is an isosceles triangle. What else do I know about an isosceles triangle? It has base angles equal to each other. Therefore, angle A becomes equal to angle B. Do you see? That's because I was told AC is equals to BC. So that's how you then try and understand your diagram. Lastly, you mark down what you need to find or prove. Please understand this. Let me make an example. If I give you that diagram, the triangle, right? And then that's A, that's B, that's C. And then I want you to prove that, the question says prove that AB is equals to AC. Please understand, this is not what you are required to prove. No, this is the conclusion you are going to draw after you prove what makes AB to be equal to AC. Because you can't measure them, remember that. Now, what would make them to be equal? It would be the angle C being equal to angle B. So in actual fact, my RTP, which is required to prove, they want you to prove that angle B is equal to angle C. If I can prove that, then my conclusion will then be that the lines are equal to each other. Let me just quickly repeat what I've said. The required to prove is what will make the lines to be equal in a triangle. What that is will be that the lines must be opposite equal angles. So in actual fact, they want me to prove that angle B is equal to angle C. Because if I can do that, it will qualify my triangle as an isosceles triangle. Then I can claim that AB is equal to AC. I really, really hope that clarifies how to prove things, because as soon as people see proof, you think you must use that. No, you must prove what is required for what I want you to prove to be true. Now we have a flow chart of how to go about solving these riders. Firstly, you read through the facts part, right? The facts part, we are talking about what are you given, right? This is the given information. You mark all of this given information on sketch. What does that mean? It means you indicate them. If I say parallel, you know there's arrows that you draw to say these lines are parallel. You show that. And then from there, you mark the implicit facts. What do you now know because of the lines being parallel? What do you now know because of the lines being equal to each other? And then you read through the facts part again, which means you look at, am I done with what they have told me? And then you devise a plan of action. Don't go blindly into the questions, guys. Please, you make a plan before you can answer. You don't thumbsuck answers. You make a plan to say, okay, for me to prove that these are equal, I must prove this. So if I can prove this, I will need to do this. Then as a result, I do this. Then this will limit you having a list of unimportant things when you are trying to prove certain things. Then lastly, you evaluate your plan and then you restart based on whether it is correct or not. And it has nothing to do with really being correct. It is about, does it make sense, right? Because it really needs to make sense to you. You've been doing this math. Now, let's try and apply all of this into a diagram. It says the figure shows a large triangle with vertices A, B, and D, and a smaller triangle with C, D, and E. Now, the point C is the midpoint. As soon as I know that, I am definitely going to the line BD, and I say BC is equals to CD. And then E is the midpoint of AD. It means DE is equals to AE. Do you see? Now, what is this telling me? It is telling me that this line will be parallel to that line. Sorry, that will be the implicit information based on the fact that these line segments are bisected. Now, to try and see what they want us to do with this, firstly, they will say we must find the angle DCE. So let me add my data first. Remember, that line is equals to that line. This one here is equals to that one, meaning this is therefore parallel to that. So simply, you're going to start by first saying CE is parallel to BA. And then your reason will be midpoint theorem. Midpoint theorem. You don't need to prove the midpoint theorem. Remember, guys, in Euclidean geometry, once you now know the theorem, only when they want you to prove it do you prove it. If you are using it, you just state it. And then if I know that, then I know that the value of X will be corresponding with the value of B. And then this angle E there will be corresponding with angle A. So as a result, I will then say that my DCE, which is the same as X, this will be equals to the angle B, and that is actually equals to 89 degrees. And then your reason will be corresponding angles because, remember, my line BA is parallel to CE, or CE is parallel to BA. Is really up to you how you write that, right? And then that's how you can then find what the angle DCE is, which is as simple as you finding X. Now, they want you to name the two similar triangles in the diagram and then give a reason for your answer. Please remember, as soon as we talk about similarity, we then need to talk about equiangular, right? We need to talk about equiangular, meaning the corresponding angles are equal to each other, right? So, with this one, I'm just going to draw a table. It normally makes it a bit nicer in terms of when you're writing down what you want to write. Statement, which is S, R is a reason. My very first statement will then be, I want to talk about, firstly, the angle B being equals to the angle DCE, and then my reason for that will be corresponding angles, right? And then I also know that my angle A will be equals to my angle CED. That is also corresponding angles. Please remember to indicate the parallel lines. CE is parallel to AB. CE is parallel to AB, right? Parallel to AB. And then lastly, you know that you will just say D is common. D is common. And then based on that, I will say triangle A, B, D is similar. Remember, similar is three vertical lines to triangle. Now, the angle at A was equal to the angle at E, right? So that will be E. The angle at B was equal to the angle at C, so that will be C, and then the angle at D will be equal to the angle at D. So that is ECD, and then your reason will be angle, angle, angle. Now, that is because we are talking about equiangular. You don't really need to write equiangular, just say angle, angle, angle. It really means that. Now, consider the triangle below, which is PQR, right? Now, they've showed us a few things on this diagram. One, they told us that Rx is equals to XP. So this is actually X, guys, and that is Y. Not that it's X of an unknown, it's a point. And then Ry is equals to YQ. What do we know here? What is implicit about this? The implicit thing will be this is going to be parallel to that because of the midpoint. Because of the 5 centimeters there, or 5 units rather, because they didn't give us units, I will then say this is 10 units because remember they have a relationship of 1:2, right? To apply this now, they want me to talk about the relationship between X, Y, and PQ. So firstly, you will say Rx is equals to Px, and then you will say Ry is equals to YQ, and all of this is given to you. That will be a reason there. And then as a result, you will say XY is parallel to PQ, and the reason will be midpoint theorem. And also you will say XY is equals to 2 times, or half rather, not 2 times, PQ, right? It is half of PQ. And that's what the relationship is there. And then the last thing that you need to look at is to find the lengths of the sides of PQR. As soon as I know that this is 5, and that is 6, and that is 8, I can then use those because I know this is 8, I know that is 6, and this is 5, it means that is 10. So the lengths of PQR, you don't really need reasons for those, but you will just say PR is equals to 6 multiplied by 2. This is a given, and then you give me what you give me the value. And then similarly with RQ is equals to 8 times 2. And then lastly, PQ is equals to 5 times 2. All of them it will be given. Only this one will you then say the reason is midpoint theorem. And that's how you then apply the midpoint theorem. Hi guys, welcome back to our lesson. So we are still looking at revising Euclidean geometry, right? So we did look at the midpoint theorem. Now we're going to continue with applying this midpoint theorem in trying to solve some questions. So let's just jump right into the questions. Now, when using the midpoint theorem, you need to make sure that you know you're going to use this either to find unknown sides and unknown angles, or to actually use it to find the properties or to prove the properties of quadrilaterals, right? Like, for example, prove that ABCD is a parallelogram. That's one of the ways you can use this. Now let's actually see what is it that we need to do in order to apply this. Now they say K is the midpoint of FG, of parallelogram FGHJ, right? Now as soon as I see the word midpoint, right, of FG, where's my FG? So it means that the two-liner there and the two-liner there means FK is equals to KG, right? And then this is a parallelogram. As soon as this becomes a parallelogram, it makes then the two opposite sides to be parallel and equal to each other. Now, GI is drawn parallel to KJ, right? GI is drawn parallel to KJ. If that is the case, it then kind of tells us already that this liner here will be equal to, let me make it three liners, will be equals to that one there, because you can apply the laws that have to do with the midpoint theorem. And then also it intersects FJ that is produced at I, which is just a point, and then prove that JH is equals to prove that JH is bisect GI, right? So we need to prove some equality there. The J and the G are really confusing at times. And then the note that you need to know before you can even solve this is the concept midpoint and parallel lines already tells us that there's a possible way of us using the midpoint theorem in terms of being an application of it, right? You also need to remember that in a parallelogram, the diagonals normally bisect each other. That is very key. Also, you need to know that you remember the 5 ways in which a quad can be proved to be a parallelogram. Now, if we apply the midpoint theorem here and look for a parallelogram, we can then claim that we know this Fj is equals to Ji there, because that's where the midpoint theorem will be. And if that is the case, it then means that Jk is half of Ig, right? Or Gi, rather, if we can use it like that. So that's one of the things we can talk about there. And then based on that, we can try and throw in some parallelograms, which I'm going to do with a broken line now. So we are going to prove that GH is bisecting, JH is bisecting GI. Guys, this J and G are really, really confusing because they kind of sound the same at times. So if I want to prove that these are bisecting each other, that's JH then and GI. So this point here, it must be a point of bisection there, right? But now, what do I know so far? I know that this side is twice that side there, right? So if that is the case, then I will need to try and see whether JGHI is not a parallelogram or not. Because if it is, then I will have proven what they want me to prove. So automatically, based on that, I will just say, number one, I know that GH is parallel to JI, right? And that will be a given because it's a parallelogram, so this will be a given. And then we also know that JF is equals to JI, and the reason for this will be midpoint theorem. Remember I said there's where we can apply it, midpoint theorem. And then based on this, we know that we can then say it means J or JI is equals to GH. Now, as soon as this is the case, it simply tells us that JGHI is a palm, right? Meaning parallelogram. The reason for this will be one pair of sides is parallel and equal. Let me just write that properly for you. It is one pair of sides parallel and equal. Based on that, then it is a palm, right? And then if that is the case, then it will be just that JH is bisecting GI. JH bisects GI. And then that will be the diagonals of a palm, right? Your reason will be diagonals of a palm or just properties of a palm. And now they give us another shape which is PQRS, which is a quadrilateral. It's not a regular quadrilateral, so that is the most interesting thing here. T, W, V, and U are the midpoints. I'm just going to stop there. I don't even want to continue. Firstly, it means T is the midpoint of PQ there. W is the midpoint of QR. V is the midpoint of RS. And then U is the midpoint of PS. You see, that's what they respectively means. And then I try to indicate them with liners, and then this is an X there, just to say they are equal. All right, so what they want me to now prove is to prove that TWVU is a parallelogram. So I'm just going to draw out the lines that are missing, which is the TW and the VU there. So as a result, you can see it makes it a not really parallelogram, a quadrilateral, which we need to prove that it is a parallelogram. To show you an actual visual of this, it will then look something like this with my dotted lines there, which are very beautiful. Now, what implicit information can I add? I actually want to add it on this diagram of mine. I know that TU is going to be parallel QS because of midpoint theorem. I also know that my VW is going to also be parallel to the QS. So meaning all three lines are going to be parallel one another, right? So in simple terms, I'm then going to say number one, TU is equals to 1/2 of QS, right? That's the first thing. And then I know also that my WV is also equals to half of QS. So in simple terms, it means that TU is equals to WV. And then my reasons for both these two will just be midpoint theorem, by the way. Midpoint theorem, right? And then now what have I done? I've proven that TU is equals to WV. Now what I need to prove is that the TU is parallel to WV. Then I will be done. So I actually did show you with the arrows, right? So we said TU is parallel to QS, right? And we also know that WV is parallel to QS. So as a result, it means that TU is parallel to WV. By the way, the reason for both these ones will also be midpoint theorem, right? So let me just write the theorem at the top there so that people don't think it's there, right? That's theorem. I'm just shortening them because space might be a problem. And then lastly, then I can claim that this is a parallelogram. And my reason for it being a parallelogram will then be because one pair of sides opposite, one pair of opposite sides, right, are equal and they are also parallel to one another. That's one of the properties of a parallelogram. Please, I said you need to revise the 4 ways of proving that a quadrilateral is a parallelogram. All right, guys, I really hope now you understand how to use the midpoint theorem and when do you then use it? What must they tell you so that you know that I need to apply or use the midpoint theorem? Guys, I want us to take a quick ad break. When we come back, we're going to do one more question that is going to try and assist us in doing the application of midpoint theorem. Please stay tuned. I'll be back just now. Hi guys, welcome back. So we are still looking at revising Euclidean geometry, right? We have been talking about the midpoint theorem. Now we're going to try and apply it to the last questions and see exactly how we can do that. So let's just jump right into what the question wants us to do. Now, the question says ABC is an isosceles triangle with AB being equals to CB, right? And if that is the case, we know now that this will be equals to that, right? Which means it's an isosceles triangle because it might be a midpoint somewhere there. And then also we will claim that that is equals to that, which the line segment. And then let's just quickly read the last part and apply what we are talking about. So D is the midpoint of AB, I've already showed that. E is the midpoint of CB, I've also already showed that. The last thing will be the midpoint of now AC, meaning this one here will now be equals to that one there. But what do I now know? I know that angle C is equals to angle A because they said it's an isosceles triangle, right? And then because I now know that, I can then talk about quite a few things that have to do with the lines being equal to each other and the angles being equal to each other based on the fact that they told me it's an isosceles, number one. Number two, they told me that there are midpoints here. So I just want to annotate this on this diagram. So if this is an isosceles and E is the midpoint of BC, it means EC is equals to BE. Remember that. Which simply means that also DB will be equals to DA. But now, do you realize that all 4 line segments will be equal? Because these 2 lines, AB and BC, are equal to each other. Do you see? And then lastly, I will have this one down here, which is equals to that one down there. So now you can see I have some interesting things that I'm going to talk about here, right? Firstly, I know that this angle here is equals to that angle there, which will be the same as that angle there because of corresponding angles. And then I just want to also label it as 1, 2, 3 like that so that we are clear on what we are talking about. So this will be 1, that is 2, and that is 3. This is 1, that is 2, and that is 3, right? And then I'm going to try and apply that based on what I've just done now, right? So I know that the angle D2 will be equals to this angle here because of the concept of alternate angles, right? But I also know that the angle E2 will be equals to that angle down there because of also alternate angles. Now you can see that based on that, I can always claim that the angle F1, right, just to label it, is equals to angle A because it's corresponding angles. By the way, let me just write all of this down so that it does not confuse you because I'm saying a lot of things. So S and R them. So firstly, I'm going to start by saying, I know that angle EFC is equals to angle DEF, right? And my reason for this will be alternate angles. And then I also know that the angle EDF is equals to the angle DFA, right? Also because of alternate angles, right? So just remember to always indicate which lines are parallel. The lines that we are trying to use here will be DE is parallel to AC, right? But now what do I know? I know that the angle EFC is equals to the angle A, right? That is because of corresponding angles, and that is simply just because EF is parallel to BA, right? Midpoint theorem there. And then as a result, it simply means that DEF is actually equal to A. And if DEF is equals to A, it simply means even my D2, according to the diagram, which is EDF, is also equal to A. You see, then I can apply that particular concept there. So I will say EDF is equals to angle C first, right? It was we were given that, and then lastly it just simply means that angle EFC is equals to angle EDF, you see, because both of them are equal to A and C, which is an isosceles triangle. And then if these two angles are equal, it simply makes it an isosceles triangle. Guys, I know it looks a bit messy, but if you follow what you needed to do there, firstly, you needed to make sure you link my F1 according to this, which is EFC, with the A there, and then you link the F3 here with the C there, and then from there you can work it out from there. So that's just what you needed to do, although it's a bit messy. Now I want you to find another way. So this will be like your homework that I want you to do, right? Here I used the concept of parallel lines and midpoint theorem, and they told me that ABC is an isosceles. Now I want you to try and see if you can maybe prove a parallelogram there somewhere, or prove using another way to try and show that that is an isosceles triangle. And then what type of quadrilateral is BEFD? So BEFD will simply just be a parallelogram, right? And you will need to motivate this. To motivate this, I know for a fact that this line is parallel to that line. That is a given. I know that this line will also be equals to that line. So it means one pair of opposite sides parallel and equal. You see, same thing that I've been using here, right? So one pair of opposite sides. You need to specifically say that it's opposite sides are parallel and equal, right? And then what quadrilateral this is, it is a palm, And my reason is what I've just given you there, right? So that's how you can talk about that. So the question says, if angle BED is 68 degrees, right? I'm quickly gonna fill it in here. And remember, we know that those lines are parallel. So in simple terms, I also know that that is 68 degrees there. Now they want me to find AFD. So to find AFD, which will be this angle there. So I want to try and find that. For me to find that angle, already that angle is actually equal to C because DF is parallel to BC. But let me write it for you first. So I will then say, firstly, BED is equals to angle C, which is equals to 68 degrees, and this is corresponding angles, right? Because DE is parallel to AC. And then from there, I also know that angle AFD will be equals to also angle C, which will still also be because of corresponding angles, but now because of different parallel lines, which is my DF parallel to BC, right? And then lastly, it means AFD will be equals to 68 degrees, and you don't need a reason for that because you would have just showed it in terms of algebra. And that's what you need to do. You just need to make sure you are clear on the parallel lines and the midpoint, the midpoints that are given. Now, please remember that with Euclidean geometry, there's what we call conjectures. These do not have proofs. It's just a statement without any reasoning. The theorems is what we've been trying to look at now, and that's what you guys need in order to make sure you understand what Euclidean geometry is all about. Guys, I know Euclidean geometry at times is a bit of a complex thing, but I promise you, if you always follow our flow diagram that I did with you, the flow chart, it will allow you to be able to know what to do after what and what and what, like that. So it will give you the order of the steps that you need to take. Guys, we've come to the end of our lesson. I hope you enjoyed everything that we've looked at. If not, I will do better next time, but I know I never do anything that you don't enjoy. Remember, mathematics is food for the soul. Until next time.